Hello, fellow colleagues. My name is Mantas Bukauskas, and I'm a software architect at Hnit-Baltic. I have been working with ArcGIS API for JavaScript for more than 8 years now, and I have an honor to present you this library today. So let's get started. Actually, this is a very broad topic that you can take. Oh, sorry, I haven't shared my screen yet. Yes, so actually this is a very broad topic that we can talk about in all the sessions in this workshop, but I will try to cover the basics of it. I will run through most important parts, which are basic concepts of how to create your own mapping application, how to use REST API, how to secure your data, how to create a new widget, what integration possibilities with other frameworks are, and finally, I will try to set you on the road so you can keep learning how to use the API. Also, all the topics will be from first version of the API, and I will be using TypeScript in demonstrations. So let's get started. So what can you do with this framework? ArcGIS API allows you to create mapping applications that can visualize and process data using your user's browser resources. API contains modules for mapping, tracking, geocoding, geoprocessing, editing, querying, and routing. Best way to start developing is actually by reading the documentation that Esri provided for us. And you will really enjoy this documentation as it is a top quality product from Esri. And Esri tries to make it as convenient as possible. Documentation is divided into 5 sections. There is an overview section when you can get familiar with the API. Next, there is a sample code section where you can find more than 300 samples and download them. Next, there is an API reference where you can find all the objects available to use in your application. Also, there is a showcase section where you can find complete solutions that you can use in your cases. Also, there is a blog section where you can find interesting articles about the API, and you really should check that out. Okay, let's move on. Installation. There are many options how you can create your application. You can use API from CDN or host it on premise. You can use AMG or ASM module structure. You can use plain JavaScript or use TypeScript. You can build your application for best performance or leave it as is. And it all depends on how complicated your application is. If it's a map with one location point, I would use CDN approach with JavaScript to keep it simple. Although if it's complicated application with lots of code, you should use TypeScript and build your application using Webpack. This way your application will be optimal for loading, and you will have optimal performance. And you will keep your intellectual property safer as application will be minified and it will be harder to be copied. Now I would like to show you how easy it is to start a new application, and Esri has provided a command line interface that allows you to create ready-to-start applications by running simple commands. So I will open my Visual Studio Code. I'm using it for development, and now we need to install the command line interface. We can do that using the command npm install /arcgis/cli. And if you use G tag, it will install it globally. But I already have it installed. It actually takes a while to install it. After we install this globally, we can use ArcGIS command to initiate our JavaScript applications. And init command actually does it inside your folder that you have context of. So let's run it. Now it creates a structure for my application. It adds TypeScript configuration, Webpack configuration. It adds all the dependencies needed for my application. Next, what we need to do is actually go to the developer dashboard and get the API key so we could run our application. So I have opened my developer's dashboard and I just generated my API key. I have to copy it and okay, it's still installing, and I will add it to my configuration. So it's a S3 config file. It has API key property, and we will set that property to our API key. We save it. And now to run our application, we can use npm run start command. What it does, it will launch the Webpack server, which will host our application, and we can develop that application directly. So anytime I will make a change, application will reload and show that change. As you can see, our application is launched and we can continue developing it. So let's go back to the slides. Sorry, 1 second. Okay. Next, I would like to go through some core concepts of the API. Developers are provided with different classes that can be used to implement map-centric applications, and I will try to introduce you with these main classes. First, what is most important part of the application is actually map and view. And what are maps and views? Maps are containers used to manage references to layers and base maps, while views are used to display the map layers and handle user interactions, pop-ups, widgets, and map location. Maps are created from map class, and map objects are always passed to a view object. There are two view classes used to display maps. It's a map view class for 2D maps and scene view class for 3D maps. There's also a web map class for 2D maps and web scene class for 3D maps. It is used for maps generated through ArcGIS Online scene viewer or map viewer, or they can be provided as JSON configuration structure. Okay, let's move on. Next important topic is layers and data. Map is a set of layers placed on each other, and the API has a number of different layer classes that can be used to access and display layer data. The layer used depends on the format of the data and where the data is stored. Each layer type also exposes a different set of capabilities. For example, feature layer data is stored in ArcGIS Online or ArcGIS Enterprise. It is used for displaying, querying, filtering, and editing large amounts of geographic features. Other example, it's a graphics layer, which data is stored in temporary browser's memory. and it's used for displaying individual geographic features as graphics, visual aids, or text on the map. Another example is CSV, KML, or JSON layer, which data is stored in a file, and that file can be displayed on your map. Also, there is a tile vector and vector tile layers, which data sets are stored in a tile scheme for fast rendering and is used for displaying geographic context for the map. Also, there is a map image layer, which data is stored in our ArcGIS Enterprise. It is used for displaying layers dynamically rendered by ArcGIS server services. Also, there is WMS, WFS, WMTS layers that can be stored externally by different mapping software or within ArcGIS by enabling capabilities for the services. It is used to display map data using OGC specification. Final one I want to mention is scene layer, which data is stored in ArcGIS data store, and it is used for displaying 3D data. Also, there's a lot more layers like stream layer, OpenStreetMap layer, elevation layer, point cloud layer, and so on. So, but you can find all the information about them in the API documentation. Next topic I want to talk about is programming patterns and how main concepts of programming with JavaScript API is. After you get the ArcGIS API for JavaScript, you can use import statements to load modules that are needed for your application. During the build time, only these modules will be included in your application, and your application won't contain any unnecessary modules. Talking about constructors, all classes in the API have a single constructor, and all properties can be set by passing parameters to these constructors. Alternatively, the properties of a class instance can be specified directly using setters, as you can see in the slide. API also supports a simple, consistent way of getting, setting, and watching all properties of a class. Many API classes are subclasses of the accessor class, which defines get property method, set property method, and watch property method. As you can see in a slide, we can use get method with multi-level property to safely get the property without causing no pointer exception. We can use setters to set the settings directly. Also, we can watch for property changes by using watch method. We provide the property name and we provide the callback function, which contains which returns properties new value, old value, the property that was changed, and the object which property was changed. Also, watch method returns a watch handle instance, which allows you to stop watching property if no longer needed. Next topic is promises. Promises plays important role in the API. Using promises allows you providing cleaner code when working with asynchronous operations. On the most basic level, a promise is a representation of a future value returned from an asynchronous task. When the task executes, the promise allows other processes to run simultaneously while it waits for a future value to be returned. This is particularly useful when making multiple network requests where timing and download speeds can be unpredictable. A promise is basically always in one of the three states. It can be pending, can be fulfilled or it can be rejected. Also, promises can be changed, as we can see in a slide, which means that we can have multiple promises that depend on each other. After one promise is fulfilled, executor moves to the next promise. If one of the chain of promises is rejected or error has occurred, catch statement will be executed. And in both cases, finally statement will be executed. Yeah, so also we can write that same promises by using async and await functions, which appeared since ESMA script 7 release, which was released in 2016. And it allows us to use these operators to have the same functionality that we use with promises. And next pattern is that Esri has provided all of the out-of-the-box widgets with a view model, which has separate properties, methods, and data inside of them. The separation of core logic and presentation makes each widget highly customizable when working with other frameworks like Bootstrap, React, or jQuery. Since each view model class extends accessor, all properties on the widget can be accessed using methods we talked about earlier. So it's get, set, or watch. The design allows developers to create new widgets and repurpose existing widgets with a third-party framework. Now I would like to show you a demo how to create your web map and load it inside your application. So I will open our newly created application. Now I will open my ArcGIS Online account. Next, I will open the scene view so we can create a web scene. Next, we will go and create a local scene. Now I need to add some layers. I found a layer from Vilnius city, which contains mesh data of the city. Sorry. And we add it. Now we can change base map for our application web scene. So we can use like photo. Okay, we can zoom into the city. And we can save our web scene. Let's call it let's give it a name and let's save it. So now let's go back to the content. So you can see a new item has appeared. It's a web scene, and I will make it public. Now I will open my application and replace some code so it would use that newly created web scene. Okay, since I changed my application to 3D application, I need to replace my init widgets method as well. because it requests the feature layer parameter that is no longer available. So I will replace code here as well. Okay, now we have our application running fine. There's no errors. And let's try to open it and see if it works. Oh, sorry, yes. I need to add my web scene item ID so it will load my application. To get the item ID, I just simply open the web scene and copy the ID of the item. And I paste it inside my web scene object, so it automatically autocasts it to the web scene item. And we can see that application already reloaded automatically, and we can see our newly created web scene. So it's that easy to change the view of your map of your application. Okay, let's go back to the slides. Our next topic is ArcGIS REST API and how to use it. Although many ArcGIS REST API requests are covered within ArcGIS JavaScript API classes like query task or geoprocessor class, sometimes you might need something specific or some parameters might not be covered yet inside the API. In that case, you can use a request utility from the framework to make a direct call to the REST API and process the results yourself. To successfully use the REST API, you should know and find the resources needed, and you can do that in the REST API documentation. There is all services section where it contains samples of how the endpoints work and what requests can be made to the API, and you can find all the needed information there. Also, to find the URL or operation that is available within our ArcGIS server, you can use the service directory. You can navigate it by using HTML and find what operations is available for you and use that inside your request. And just don't forget to set f equals JSON to return results in JSON format. Next, I would like to talk about security and how to secure your data. Actually, there are many options in API how you can integrate authentication and authorization methods. And what is the authentication method? Is a process used to obtain the access token. Your app must present an access token whenever it makes an authenticated request to a secured location services. And access tokens define the scope and permissions available to your application or to your user. The authentication method you use to get an access token will vary based on the security and access requirements of your application. Today, I want to talk about the API keys and ArcGIS Identity, which is probably most popular ways to authenticate your users. There are, of course, other ways that you can use. You can integrate network credentials. You can use ArcGIS tokens or application credentials. But today we will skip this and leave it to the next sessions. To make authenticated request to services, you need to set a token parameter to an access token, but that can be handled for you by using classes from ArcGIS core identity namespace that's available within API. Let's talk about API keys. It's a new feature that is available since 2021 January. The API key is a permanent access token that grants you public-facing application access to specific ready-to-use services. And with an ArcGIS developer account, you can access private content, items, and limited client refers. You can use global API key as well as more fine-grained API keys on a specific classes. Fine-grained API keys will take precedence over the global API key. If you are using both API keys and ArcGIS Identity, the API keys will take precedence. However, API keys are not supported in ArcGIS Enterprise yet and can be only used with ArcGIS Online account. Next option is ArcGIS Identity, formerly known as named user. It grants a short-lived token giving your application permission to access the content and services authorized to your application users, existing ArcGIS Online or ArcGIS Enterprise account. Applications that support user logins are responsible for providing a login dialog that prompts user for their credentials. The application is responsible for keeping these credentials safe, so you have to use HTTPS to handle the credentials. In this pattern, users authorize your application to access content and services on their behalf. Also, there is option to implement application credentials where users authenticate using your application credentials and your application is logged in. You can use ArcGIS Identity when you want to ensure that users are signed in and authenticated with their own ArcGIS account, meter usage of private data, content, or service transactions for the authenticated user. Also implementing these security methods can be a lot of work. So Esri has provided some classes that help to do that within ArcGIS API for JavaScript. And these classes are IdentityManager and Info. We will see soon. So IdentityManager needs to be configured to use ArcGIS Identity, and to configure it, you have to register your application with ArcGIS Online on portal for ArcGIS. Registration process provides you with App ID, which enables portal to trust your application and allows your users to sign in. Next, there is a check sign-in status method that can be used to check whether a user is signed in already or not. If user is signed in, it gets the authorization token from ArcGIS Online or portal for ArcGIS and grants access to a secured content. And if user is not logged in, it will prompt the user to enter its username and password. All this can be handled by configuring IdentityManager, and we will see how to do that in our demo. Okay, so what I will do, I will switch my API keys authentication method to ArcGIS Identity. So as I mentioned, to do that, first of all, I have to use HTTPS. So I will switch Webpack to use HTTPS. Now I will need to reload my application. Next, I will go to ArcGIS Online, and I will register my application. We click New Item, Application, Web Mapping. We provide URL of our application, so it's copy it. We click Next. We add title, so let's call it S3 2022. We can save it. Now we are redirected to our new item. We have to go to the settings. We can find the register button at the bottom. We click it. Now we choose the application type, so it's a browser application. We need to provide redirect URL where the application, where the portal will redirect users if we try to sign in. So we add it, we click register, and now we get the app ID, and we will need this ID in our application. So let's go back. Okay, now what I have to do, I will add the helper classes to configure our app identity. So we need auth info, and we need IdentityManager. Next, I will add initialization of these classes. So we construct them. We register our new information to IdentityManager. After that, we check if our user is signed in, and if it's not, he will be redirected to the portal URL and will be asked to provide its credentials. Okay, so I need to add my app ID. It's here. And now we should see. Okay, we need to reload it. It's a safe certificate. Okay, so what happened? We are now redirected to the portal, to ArcGIS Online, and it asks if we want to provide our credentials to our newly created application. We click Provide it, and we can see that our application has loaded. So now your user is authenticated, and application is secure. Okay, let's go back to the slides. Next topic in line is widgets. Widgets are reusable user interface components and are key to providing users with rich user experience. API contains 49 widgets available out of the box. Of course, some of them are support widgets, but it still can be used if you are creating your own custom widget. The API also provides the ability to build custom widgets that fit your unique requirements. As I mentioned earlier, every out-of-the-box widget contains a view module that separates him from its presentation and only provides the business logic in that view model. Now talking about fundamentals of custom widget development and the specific areas you should focus on transitioning to this framework. The suggested approach by Esri for widget development is through TypeScript. And one of many advantages of using this approach is to use of decorators to enhance functionality. Also, there's a great TypeScript setup guide that Esri provided, where you can set up your development environment with TypeScript, or you just can use the ArcGIS command line interface that I used earlier. Also, to develop widgets, you need to use GSX, which is a JavaScript extension syntax that allows to describe the widget user interface similarly by using HTML. It is commonly associated with React, but it can also be built using other implementations. Custom widgets has TS6 extension, which combines that it is created using TypeScript and using GSX syntax. Also, almost every object within a fourth version of the API is a subclass of the accessor class. So all the properties can be accessed through get, set, or watch methods. And when you're creating your own widget, you should also make sure that you inherit the accessor. And you can do that easily if you would inherit from the base widget, which is within the API. Also, there is two types of frameworks. There is a Esri framework which uses AMD module structure, and there is a ArcGIS Core which uses ECMAScript module structure. So when you are developing new widgets, it is recommended to use ArcGIS Core as it implements the same underlying functionality as AMD modules. It is recommended to use it because ECMAScript modules work seamlessly with almost all major JavaScript frameworks and build tools. You don't need any loaders or anything. You can directly use import statements and get the modules mixed with the other framework modules. Also, there is a subclass decorator which separates your widget from the widget you inherited. This helps to API to differentiate between the existing class and your newly created class. Okay, we can see in a slide the widget lifecycle. If you inherit the widget class from the API, you have to implement these methods. First, there is a constructor where widget is initially created and properties are set. Next, there is a post initialize method, that gets called after before widget is rendered and after it's created. Also, you have to implement the render method, which returns the Y that widget needs to render. Finally, there is a destroy method where you can add your statements where it cleans up all the event hooks and make sure that any unnecessary data is removed. So the widget development consists of these steps. It's extend the widget class, implement properties and methods, implement the render method, and export your newly created module. Now let's try to create a new widget for our application. To do that, as I mentioned, I need to provide some TypeScript configuration parameters that will allow us to use experimental decorators. Also, we provide the configuration that we will use JS6 syntax in our classes, and after we do that, we need to reload our application as well. We need to stop the webpack server and relaunch it. Sometimes it is useful to relaunch all your editor because it reads your TypeScript configuration, and if we will get some errors, I will do that. Okay, next let's create a folder within our source. Let's call it widgets. Now let's create a new file called custom.tsx. Now we need to import some objects. So we import widget from widgets /widget, and we import tsx. So compiler will know that this widget is using tsx and JS6 syntax. Now we write our code for custom widget. So we use our export statement. We extend widget. We provide some properties. We implement methods. So it's constructor, post initialize, which is empty. We add render function, which is using JS6 syntax. As you can see, it's similar as HTML, but it has some dynamic parts that are separated by the brackets. Finally, there is a destroy method, but we don't add anything, or we don't add any event listener, so we don't implement it. Okay, so we now have to save a widget. And now we will try to load this newly created widget. To do that, we will go to the widgets.ts. We will import our widget to this file. Now we will construct our widget. We will provide a widget with the scene view. Next, we will use few method to add this widget to the bottom right of the application, and we click save. Now we will open the application. Oh, sorry, yeah. I haven't launched my application yet. So I launch it. And hopefully it will load. Yes, and we can see our newly created widgets in right bottom corner. We can modify it a bit, and we can provide a parameter which we added its name. We can write it the developers. Application reloads. Now we see that our property is red and we have a new value inside our custom widget. Okay, let's go back to the slides. Now let's move on to the API integration with other frameworks. As I mentioned earlier, API can be integrated with many third-party frameworks, especially since ECMAScript modules became available in 4.18 version of the API. After this change, you can use ArcGIS Core to integrate API with every framework that supports SM modules, and you can do that easily. Esri has provided many samples on how to integrate them with most popular frameworks, and you can find these samples within Esri GitHub account. So there is a sample applications that that is integrated with Dojo2, Angular, Ember, React, Vue, Leaflet, Ionic, and so on. Also, I would like to mention the low or no code applications where you can use JavaScript to extend them or just configure them without extending. So one of them is configurable apps, which is available in ArcGIS Online. It provides a suite of application templates that can help bring your stories to life. Next one is ArcGIS Story Maps, which is a digital storytelling tool that helps you create engaging web pages with photos, video, audio, ArcGIS web map or web scene. Also, there is a ArcGIS Experience Builder, which empowers you to quickly transform your data into compelling web apps without writing a single line of code, or you can extend them, and my colleague will talk about it later. Finally, there is a ArcGIS Web App Builder, which is what you see, what you get application that allows you to easily build web maps, web apps, and it includes powerful tools to configure fully featured HTML apps. Okay, finally, I want to set you on a road. So Esri has provided more than 300 code samples. You can find them within API documentation. Also, there is a JavaScript API resources where you can find some starter applications, which allows you to quickly use different type of third-party frameworks and launch your application quickly. Also, there are a lot of step-by-step tutorials within the documentation where you can just try out the API. Nonetheless, there is a broad community where you can find help if needed. And that's it for my presentation. Thank you, and I hope you have learned something new today.